Hi, in this video we will solve a problem related to the boundary conditions. In this problem they mentioned about what two extensive homogeneous dielectric meet on plane z equal to 0. For z is greater than 0, epsilon r1 is 4, and for z is less than 0, epsilon r2 is 3, and a uniform electric field with E1 equal to 5ax minus 2ay plus 3az exists for z is greater than or equal to 0, like this. For z is greater than 0, E1 is like this with epsilon r1 as 4. Find E2 for z is less than or equal to 0. So, means we need to determine the electric field in the second medium with epsilon r2 as 3. By using boundary conditions, we can determine the field on either side if you know the field on the other side. So, here we have E1 means on this side. So, for z is greater than 0, we have the E1. We can determine the E2 for z is less than 0 by using the boundary conditions. What are the boundary conditions? These are the boundary conditions. So, this is the given data E1, epsilon r1, epsilon r2. We know that E1t equal to E2t, T1n equal to D2n. Okay. So, this is the plane. What is the normal to this plane? This is the normal. Okay. So, that is why the normal component of E1 is nothing but what? E1n is nothing but what? 3az. Normal component is along a z direction. It is a simple technique. If they mentioned about x is less than 0, x is greater than 0, x is less than 0, means what? So, the normal component should be along x. If it is y is 0, y is less than 0, y is greater than 0, normal component is along a y only. So, as it is the normal component, what about the tangential component? E1n is this one, means remaining part, that is nothing but what? Tangential component. So, that is why E1t is nothing but what? 5ax minus 2ay. So, therefore, E2t is nothing but what? As tangential components of the electric field intensity are equal, E2t equal to what? E1t. What about this? That is 5ax minus 2ay. And E2n. In order to determine E2n, we need to go for this D1n, D2n. Okay. Basically, D1n minus D2n equal to rho s, or else D2n minus D1n equal to rho s. We can take either D1n minus D2n or D2n minus D1n equal to rho s, depending upon the given situation. Okay. So, in this case, they did not mention about that rho s, that is surface charge density. That is why we need to assume that this boundary is free of charge. Boundary is free of charge, means rho s is 0. So, as rho s is 0, we can take D1n equal to D2n. Therefore, we can write from this one E1n d equal to epsilon into E. So, that is why we can write this one as what? Epsilon 1 E1n, epsilon 2 E2n. What we required in order to get this E2? E2 is nothing but what? E2t plus E2n. So, that is why we require this E2n is nothing but what? Epsilon 1, means that can be written as epsilon naught epsilon r1 by epsilon naught epsilon r2 into E1n. So, this epsilon naught cancelled out. What about epsilon r1? That is 4. And what about epsilon r2? That is 3. And what about E1n? That is normal component of E1 is nothing but 3az. So, here 3 cancelled out. Finally, we got this as 4az. I will write that E2 here. We know that E2 is what? Any vector quantity is sum of what? Tangential and normal components. E2t plus E2n. What about tangential component of E2? That is, we find E2 as what? E2t as what? Tangential component is nothing but 5ax minus 2ay, and normal component we need to write, sorry, here I wrote E2t plus, actually it is E2n. I wrote E2t, but it is E2n. What about the normal component? We find E2n as what? 4az. So, that is why it is 4az. So, this is about the calculation of the electric field on the other side. If you know the electric field, if you know electric field on one side, we can determine the electric field on other side by using boundary conditions. So, this is the problem related to the boundary conditions. We will meet in next video.